Great. Thank you so much, Jess. Really pleased to be able to speak with you today. I have the fantastic opportunity to talk about how AI is transforming the entertainment industry. I'll just give everyone just a moment here to come back to their seat as these lights come up. There we go. Maybe the music will draw them back in. Here are some fantastic examples of great computer graphics as well as artificial intelligence augmented. I always love it when the robots fall over. So we're going to unpack some of these AI examples today, and happy to talk with anybody after the talk as well if you have further questions on this. So NVIDIA is engaging in just a huge amount of research. You'll know us as a computer graphics company, but we think of ourselves as an artificial intelligence company, and we are mostly made up of software engineers. More than 2/3 of the company is made up of talented women and men who write code for our different platforms. This is a view of Endeavour. From Endeavour to Voyager, we have Star Trek named buildings, and this is the space between them. So from a computing platform standpoint, many of you have NVIDIA GPUs in your workstations, and you utilize them in the cloud on Azure as well. But we also make CPUs and network interface cards. We have Mellanox networking capabilities. So we're an end-to-end hardware solution, but as soon as you go up the stack even a little bit, you get into the rich software layers that we have. CUDA has been a hallmark for high-performance computing, as well as RTX for real-time ray-traced accelerated graphics. On top of that, we have NVIDIA AI and Omniverse frameworks, and that enables all of the production and application capabilities that sit on top of this. So what we're presenting here is a full stack capability of hardware across the realm, as well as software capabilities that enable you to build generative AI capabilities into your workflows. We also accelerate across all the different industries. So within media entertainment, we have gaming, we have streaming, VFX production, of which I have a background in, and then of course, everything across healthcare, automotive, manufacturing. The interesting part is there's massive crossover between those different industries. I had the pleasure of working in visual effects for more than 20 years. I spent time at ILM, Pixar. I was a CG supervisor at Framestore before I moved to Google. But I'm really thrilled to talk about DNEG today. They have a fantastic ability that they are deployed to have accelerated capability for their workflow and for their VFX artists. If you think of the number of shots that exist, the idea here is generative AI is helping artists be more productive and be able to hit art-directed cues that are required in a shorter period of time and produce visual effects and transport audiences in a way they haven't been able to do so in the past. The generative AI moment for us is the idea of anything to anything. So I'm sure everyone in the room has gone text to ChatGPT and back, and then spoken to ChatGPT. You may have updated your iPhone this morning to 18.2, so you're using ChatGPT as part of your daily interaction with your data. If you go beyond that, there's text to animation and text to video. You'll notice that Sora from OpenAI recently released. There's some really compelling capabilities that exist out there today. And from a VFX production standpoint, I'm thrilled at how art directable they're becoming. There's a little bit of prompt engineering you need to learn in terms of, if you're working with Runway, for instance, how do you ask it to work with the imagery you've presented in order to get the imagery you want out? And I'll show you some examples of that in a minute. But the big idea here is that there's no limits to this as we move into 2025. You can go speech to animation. It's phenomenal. In terms of ecosystem, there's a giant logo garden for you here. It won't be up long so quick. But the idea is that we're working with all of these different companies, both from a media standpoint and from a tools and production platform standpoint. Everyone got their photo? Okay, here we go. So for Runway, text to video, I found it super compelling to be able to, the first time I did it, type in a prompt and actually get imagery back, and then go back. I'm getting nodding in the audience. Thank you for that. I'm not alone. So the idea of being able to go through and then iterate on that, and I did so with my children, and they had better ideas than I did, and they were able to see images back right away. So I'm viewing this as a pre-production storyboarding capability, the ability to really quickly turn your ideas into visual capability. And yet, the opportunity to take it farther down the pipeline is there as well. So I'll show you the Gen 3 Alpha trailer from Runway ML. So we're really proud to be the AI company that works with all the AI companies, and I'm incredibly impressed with that. The idea of being able to just think of where we came in the last 2 years. I mean, that wasn't possible. To quote our favorite YouTuber with 2-minute papers, what a time to be alive. It's really exciting to be able to see the progress that's occurring and the opportunity to see where this is going to go. This is entirely more art directable than it was even 18 months ago. It's not final film production ready, fully admit that we're not at that level yet, but the opportunity for individuals who don't have the production capability or value to be able to get there, this capability exists today to be able to provide intercut scenes. So if you're shooting in a volume and you want to shoot outdoors and you want to be able to either see what that's going to look like, plan it, or as this progresses, you could conceivably use this imagery for what this looks like in an outdoor environment cut. Now, turning this back around to more of an analytics conversation, 12 Labs is able to go through and look at a large volume of content and provide personalized information. So let's say you put this on the server side with a broadcaster rights holder, and they have a hockey rights holding capability, or it's baseball or basketball, and you say, I want to produce a highlights clip for tonight. Well, not long ago, that was done in a manual way in an editorial capacity. Of course, you can imagine, let's make a highlights reel from the game. But what happens if you have people in Michigan who want to see a highlights reel with their team versus another team and they want to intercut? Or if you're watching soccer and you're excited about goalies, or you only want to see goalies that are from the East Coast, and you can see where this goes. So the idea of being able to produce personalized content for individual subscribers is available today. And the idea that there are models that can look at this imagery and determine not just who's in it with optical recognition, but what's happening in it. And you can say, in this case, describe what's happening. And this is an astronaut jumping out of a space lock. Not realistic, but it understood what was happening. And that same analytics capability is available across broad, significant amounts of library information. If you have petabytes of video content, this technology can certainly help you with that. And 12 Labs is leading the way with a partnership with us. Now, this is something that I've found really compelling. I had the pleasure of working at ILM back on Star Wars 2, and we had Natalie Portman walking down the stairs. There were multiple dialogue modifications from George on that, and there needed to be a rig. It was either a 3D rig dropped in or a 2D comp pass to go through, and an ADR pass, and so on. How do you do that today? Well, you use the same VFX artists, the same talent that they have, but you give them better tools, and you give them AI to be able to help them along in that process. This is a great story, which I'll touch on its impact to the industry after.
Without being able to use Deep Editor, this would have been a small, restricted film that had a much smaller audience.
When we were filming the movie, we didn't know if we were R or if we were PG-13, so I said the F word so many times. I think Scott wanted to kill me in post when we were trying to get a PG-13 rating.
You're stealing my car! What? No, you mother... What the hell?
We got to the end of the movie and realized, oh, we got a great movie, but no one's going to see it because it's a restricted R. And the distributor, Lionsgate, they're like, we love the movie, but we can't release it wide. There's a limited audience to this movie because it's restricted. It's like, right, we're going to have to reshoot it if we're going to be able to change that fact. But for a movie like this, we can't reshoot it. We're not a big tentpole. We don't have the resources. We don't have the time more than anything else. And really what saved this movie and brought it into a wider audience was technology.
Now we're stuck on this stupid tower in the middle of nowhere. And I don't blame you, and now we're stuck on this stupid freaking tower in the middle of freaking nowhere. And it's all my fault.
We were able to change dialogue, change performances, essentially do a post-production reshoot of the movie and enabled it to get a better certificate.
What an incredible tool that we now have to do this. This brand new technology is really going to change the way people film.
So I think it's a really thrilling example of being able to give artists and production teams the capability to undo something. I mean, who's worked on a film where the rating changed midway through the film? I got into a film where we were, principal photography completed, and we were into hardcore into VFX before they changed the rating and cut, 20 minutes out of the film, which, anyway, disaster. But we had to, you have to roll with it. There's the date, you have to hit it. These tools enable production teams, directors, talented VFX artists, all the teams currently doing this work to be able to do more and to be able to do things that weren't possible at scale. So we think that's a really compelling example of the technology and a great use case. So de-aging. As we all age gracefully, there are actors who are super talented that would love to see on screen that may not resonate with younger audiences. That's one use case. Another use case is moving back in time. There are narrative opportunities to say, we're telling a story in today's time period, we're going to tell one in the future that also has backstories that you want to go back and visit. Or you want to be able to employ the oft-used time travel capability to say, here we are, and the characters are de-aged that didn't engage in the time traveling capability. So we're working with Vanity AI around de-aging. So there's real-time technologies that allow the production and directorial team on set to see what's happening in real time. You could de-age me now on the back. Or you can do so in super high quality in post, and you can do it at scale. So I'll let you see a little bit about the work they're doing here. So you can see the capability of being able to take 10, 15, 20 or more years off an actor, and to be able to do it without having to use specialized camera rigs and additional multi-camera rig setups. You can obviously achieve amazing quality the more specialized you go, but the idea of being able to say, we shot this, it's all in camera, there's one camera, we don't have tracking, we're going to de-age this in post, that is here for certain types of productions. When you engage with an avatar, you get a more compelling experience than if you're just typing or if you're chatting. In the same way that if you're on a Teams call and you're talking with people and it's just a bunch of face bubbles and names, that's not as nice as if the cameras are on and you're looking at people. There's a greater sense of engagement when the team turns their camera on and we're all talking. It's a similar capability when you're working with an avatar. My parents would prefer, when given the choice, to be able to talk with somebody that they're familiar with, even if it's an avatar, versus just having a telephone call. So we're all in on digital avatars. We have a great capability and work with Unreal Engine in this example, specifically with MetaHuman. And we have an audio-to-face technology, which we'll demonstrate in just a moment, and that gives you the ability to take an audio sample and convert it into facial animation. It's not just lip sync, it's working the facial muscles. There's an emotive capability which you can tune. We have an audio to emotion engine as well that, when coupled, can drive facial animation that is compelling, and it can remap across multiple characters, and it can also run just as an API, so you can consume it and stream it to a device as well. So this doesn't have to be just I'm in front of a workstation or a laptop experience. This can be fully mobile at the edge. So this is James, who is an actor that has been scanned and then given a voice with 11 Labs. And you'll notice that he is, for those computer graphics nerds in the room, fully ray-traced subsurface scattering in real time.
NVIDIA ACE is a suite of cloud-native AI microservices that enables developers to build and deploy intelligent virtual assistants and digital humans at scale. An NVIDIA NIM Agent Blueprint is a pre-built, customizable template for creating AI-powered digital assistants and virtual humans.
Okay, so James just said a bunch of things that we'll talk about in a moment here, but the idea is uncanny valley. You want to be on the higher 90% side of the uncanny valley. You don't want to be in the valley is not a happy place to be. So you're either stylized and you're in, for instance, MetaHuman with Unreal, or you can push over into something that's even more photorealistic and bring the scan truck by and take your character, build it, and then modify it from there. The most important aspect here is that all of the core technologies, think there's roughly 10 put together here, all go together like Lego bricks, and they can all be swapped out and changed interchangeably. So there's no lock-in. You just use the best thing that's available at the time. So in terms of our platform for this, the idea is that there's generative AI, which we've talked about a little bit in terms of image creation. Data analytics, really important to be able to figure out who's watching what and track production, and not only from a pre-production, production, but post-production and streaming content standpoint. Recommendation engines we're all familiar with. We use them every day when we consume content or shop. And then, of course, speech and vision, the idea of being able to go beyond text bubbles and such, and even a voice conversation, but have more meaningful conversation, to have the camera on your device looking at you and provide eye contact and be able to understand where you are, and for the device to be able to be using cameras front and back to understand where you are in the environment, what you're looking at. What's your opinion between these two pillows? I like the orange one. There's a conversation you can have with your AI agent. And then, of course, what does that look like to actually put it in production? Well, it's personalization. If you're trying to choose what car you want to buy, or what you're having for lunch, or how you want to consume your content, I want my kids to be able to have an interactive experience with Bluey, decorate their room, and then when they watch the linear content, have the bedroom they decorated be inserted into the stream, so it was the experience they had, but they're watching it transparently. That level of personalization is possible with this technology. From an immersion standpoint, we have Cloud XR. We have the ability to stream directly to head-mounted displays, Meta, Apple Vision Pro, but you can stream with high-quality, large capacity GPUs, and that gives you wildly more image complexity and fidelity than what's possible on device. And we think that's a really thrilling use case. You can have multiple people in the scene, and you can engage, as I mentioned, head-mounted, or you can have a phone or tablet and have an augmented reality experience that's happening simultaneously that's shared. And we find that, we feel it's incredibly immersive to be able to have that level of flexibility. Interactive experiences. If anyone's played Cyberpunk, for example, in that game, you walk up to a non-player character and you pretty much have one line of dialogue, and they say, "Why are you here?" Or, that's it. But the idea of having a large language model-backed non-player character, hugely compelling for gaming examples, specifically around the fact that you can have a conversation with other players in the game, and it's state aware, so they could understand that you went to the mine and did the thing and came back with the artifact, and they can talk to you about next steps, and they don't have to be part of a narrative. So we think from an interactive experience and immersion standpoint, the combining of clever avatars with audio to face and audio to motion, so that if they're reading the tone of your voice, they're reacting appropriately, so you have an acting experience, you're engaging in role playing. And then, of course, streaming technologies. The opportunity to have personalized streaming content, which I gave for the children's example, but also the ability to say, I have a live content, and I want to be able to personalize the cuts that are coming. You may have the main cut that you're putting out, but you may want to have personalized cuts that are tailored more to either different countries or different people who want to see different things. So if Manchester United's playing, you might have a cut that's more specific to one part of the country than the other. Foundry services. So we produce foundational models that are proprietary to NVIDIA that we make available to people, but we also take open source technologies like Meta's Lambda technology, and we'll take the Lambda model and we'll optimize it and accelerate it so it runs incredibly quickly. So whether it's proprietary, closed source, you developed it, we developed it, it's open source, any of that, it's all accelerated, you choose. And the opportunity to work with, it's slightly technical, but here we go. The idea of, I have retrieval augmented generation on here, and the idea is that you take a foundational model, and then on top of that, you add your proprietary data, and then you use this RAG on the front end that handles the query. So it goes something like this. You have a huge backstory for your science fiction universe that doesn't exist on ChatGPT or Meta's LLM. You put that in a special place, the query comes in, and if we're talking about your amazing space universe and the planets and the people and the starships, your special knowledge gets pulled out and responded to. But if it's general knowledge about traveling in space or planets and such, it goes to the standard model. So the idea of being able to not have to train your own foundational model, but utilize the ones that exist and then put your proprietary data on top of with a RAG on the front end, that's simply how that architecture works, and that's fast and available today. So Edify is a great example of a architecture. I'll use Getty. We all know and love Getty. The idea is that they have a huge amount of imagery, and we want to make sure that this is ethically sourced and that the rights holders get compensated and paid. So if you're a photographer for Getty, you have an agreement with them to use your imagery. You can use, Getty is using Edify to be able to go through and generate imagery based on this source image catalog. And the magic here is that the rights holders get compensated, and from a corporate entity standpoint, a production standpoint, you can utilize the imagery that Getty is then creating with you and licensing to you. You can utilize that commercially and know that you're not going to get sued for it because they are the rights holders to all the source imagery the model was trained on. So that's one way that we're partnering to have ethical AI capabilities. Now, in addition to that, you can generate all sorts of interesting, useful images. So for instance, you can generate HDRIs for use in virtual production, and you can do so for materials production. And most importantly in this example, temporally stable videos. Early on in diffusion imaging, it was possible to make a still, but if you wanted to make something that occurred over multiple frames, it was more challenging. Runway ML, Sora, those models are handling this problem really well as well. Now, I touched earlier on NVIDIA inference microservices, and James talked about it a little bit. What this is that capability I mentioned a moment ago. This is this AI capability in a box. It runs as a container. You can access it through an API. So it lowers the barrier for what you have to do. It's great to look at examples and talk about how you could use it. The NVIDIA inference microservices, NIMs as we call them, allow you to consume them. If you go to build.nvidia.com, you can see all the NIMs we have available, and you can see how they work together, and there's live examples that you can play with. In fact, James is available on build.nvidia.com, and you can have a conversation with him. You're limited to a couple of minutes. You can talk to him about whatever you like, and he happens to be an expert in NVIDIA products and services, but you can also turn that off, and that's that reg function I mentioned. If you turn it off and ask him about our products and services, he just has general knowledge, but if you turn it on, you can see he has specific knowledge, and that's a good example of what it's like to be able to use a rag with an avatar. So we have NIMs across the realm of what's possible, and then in addition to that, we have blueprints. So think of NIMs as the ingredients, and blueprints are the recipe, if you want to think of it, just to give a cooking analogy. I'm oversimplifying. But the Digital Humans blueprint is downloadable, and it's available for you to use. And this capability allows you to build a similar capability to James, or you can, as I mentioned, out of the box, you can build a MetaHuman in a couple of minutes using Unreal Engine, and then you can use this framework, this blueprint, powered by NIMs, to be able to enhance it and access that proprietary data that you put on your LLM reg backend. So you would have an avatar that could talk about things that ChatGPT couldn't because it doesn't have the knowledge that you do with your proprietary data. That's pretty exciting. Okay, and at the director's chair, the idea of producing hyper-personalized content, that's upon us now. So I'm a huge fan of linear content, cinema, big film fan. I'm also excited about content that is highly specialized to me and my interests. And the capability to do that, the tools to do that, are here for you today. So again, the thrill for me is the fact that instead of having to have a very large engineering team that was crazy clever at putting this all together, you can use a smaller team, still crazy clever, but a smaller team that can go through and utilize NIMs and blueprints and combine any bit of open source and proprietary, but it's all accelerated and it's available for you to be able to use. This is a nice example from WPP in terms of personalized content. You'll notice that they're selling you a car, but depending on who you are and where you are, there's a kayak on top of the roof, or you've got skis on it because you live in a winter environment, and the model just goes through and personalizes the content based on your interests, and it targets this to you. So if I'm from Canada, and I originally am, and I am out at Whistler, and I want to see my amazing Subaru product ripping through the mountains going to Whistler or going to Tahoe, or Mammoth, I want to see this picture, and I get the bottom one. But if I'm living out on the East Coast, I'll get a different picture. And the same thing goes for personalizing the car. Depending what market you're in, it's going to be white, silver, or gray, or black. But you may be in a market where orange or red or ruby red is the new fashionable thing. It's more than 8 months between the time that the marketing team decides to say, we need a new color, and they put that in production with the paint shop before it gets all the way through to the website. The automotive customers we work with tell us that they're literally days between when they decide to do it, between when the time it goes live. And that's compelling for content creators to be able to shorten that time period. It allows creatives to be able to be involved in this process and to be able to effect change really quickly. So how do you get started? Well, I mentioned you can go to build.nvidia.com. There, I've said it 3 times. Okay, that's enough. The idea is that we also have an Inception program. I've had 2 people walk up to me this morning and say, hey, I've just joined the Inception program. What are my next steps? The Inception program is something you should check out if you have an AI startup. I'm hoping that when I first moved to LA, I felt everyone I met was writing a script. I now feel that most people I meet have an AI startup. So hopefully you're in that club. If you are, please join our NVIDIA Inception program. And it gives you opportunities to engage with our developer relations and developer community. We also have great online forums. And then, of course, media entertainment studies. I have a strong M&E background, passionate about it. We have a large M&E team and a significant devotion and commitment to this space. We're very keen to work with you and hear your ideas and understand how we can work with you. Now, I have something exciting. This is basically the second time this has been shown outside of our research team. The paper was released at SIGGRAPH, but not the video. And I'll play it, and then we'll talk a little bit about it in a moment.
Captures with commodity hardware like an iPad are common, but often require offline camera optimization and still result in static 3D scenes. We will first use an iPad to create a fast, imperfect capture of an on-stage physical scene, such as the Gaussian splats shown here. Then, we will show that even this raw capture can become interactive in just a few minutes. Wouldn't it be nice to simply click on this object and select it? Now, let's move the object around. We didn't capture this part of the table, did we? Never mind, we can inpaint the missing part directly in 3D. Rearranging objects in the scene is fun, but it doesn't feel like the real world. How about we drop these objects on the table? Our method works even for fast commodity captures like this, artifacts and all. Rigid simulations of the objects in the scene we captured is just the first taste. Using our work, we can also simulate deformable objects directly in this captured scene, supporting multiple materials. Now that we have an interactive scene, there's so much more we can do with it. In our demo, we will challenge the graphics community to transform real-world captures into editable simulated environments in just a few minutes.
Okay, so my ask is that you put the crystal ball forward viewing lens on for just a moment and imagine where that research will be in 18 to 24 months when it gets productized by the ISVs that we work with, the Adobe's, the Autodesks, the side effects, the Unreal, the Epics, and so on. So that is raw. Like that was the leader of that engineering team who actually did the research, who recorded the video. We love our researchers. The thrilling bit is that's programmer art, engineering art. Okay, so that's for the computer graphics nerds in the room. That would be neural radiance fields and Gaussian splats. The paper's available. Feel free to read the abstract and the whole thing if it interests you. But the thrilling bit here is that you can utilize a camera to image a scene, and then you can go through and in-paint the bits that you didn't image that were obscured by other objects and use AI to do that. And then you can have a physics-aware, real-time physics environment, and we showed both rigid bodies and deformable bodies. It's not that big a jump to put rigs into those characters. We also have other research where you type in text and say, man gets up, walks, jumps, and then you can go through and pause that man jumping and then put him into a somersault and then press play, and he's physics aware and he'll complete the somersault and stick the landing. So that's a piece I can show in the future, but the tech exists. So if you combine those two techniques, now you have art directable capabilities that come from doing a scan. So we're really thrilled to see what people do with these amazing artificial intelligence technologies. So with that, I'd like to thank you for your time today and for the opportunity to speak with you.
So we have time for a question. Do I have any questions? I'm going to run back you here in the back. Here we go.
Thank you. Hi, thank you for your talk. I just had a question about, because there's been a lot of questions and talk about the sustainability of AI in terms of energy usage, and I was wondering how NVIDIA has balanced the high training cost and the impact on data centers from AI usage.
Appreciate the question, thank you. So need to discuss product for just a minute on that. The Blackwell technology that NVIDIA has announced is between 3 and 10 and 25 times faster depending what workload and what you're doing. It gives you a shorter wall clock time, but it uses drastically less energy. And in addition, we have both air and liquid-cooled capabilities, and liquid cooling is more efficient at higher energy usage. So the idea here is that we are substantially committed to having the lowest amount of energy usage to be able to create any of this technology. The other idea to keep in mind here is that data centers tend to be built in places that are near large bodies of water. And when you hear a number, when they say, X amount of water is consumed to be able to produce a query, it's not a quote that I think is factually accurate out of context, because a data center will pull water in from a source and heat it maybe a degree Celsius or so. And they use a large volume of water to be able to minimize the thermal rise in that. And they put the water back into the environment filtered and cleaner than it was when it came in. So that's just an example of, you build a data center somewhere where there's an abundance of power, hydroelectric power and similar, and artificial intelligence can run there. And you don't have to build a data center in Los Angeles at scale. You can run your AI workloads here if you need low latency, but you can also run them in a variety of different locations. So NVIDIA is committed to being able to have the lowest amount of energy usage, and you'll notice that we're making huge strides in that area generation over generation. Any more questions for me today? We have several hands up.
All right. We have time for one more. So
One
this will
more.
be the last question.
First of all, I'll try. Thank you for speaking with us.
Thank you.
So yesterday I saw Google release their Willow, their quantum computer, and it seemed pretty incredible. And I was wondering, I know NVIDIA is more focused on GPUs and graphics, but if you were to combine that technology sometime in the future, what kind of crazy stuff you guys are going to come up with?
Great question on quantum. So people have come up to me and said, so quantum's the next thing, right? When do we make the jump? And I'll tell you that 100% of the quantum companies, and again, in the same way that we're the AI company that works with all AI companies, we're the accelerated computing company that works with all of the quantum companies. We have a technology called Q-Quantum that simulates qubits. So you do the majority of your quantum computing work on NVIDIA GPUs, and then you actually run the framework on the quantum computer. But the quantum computers do relatively little work today. They'll run a workload, and there's a significant amount of research still being done on it. So we see it as an and function, not an or function. And again, the research that's being done is all running on Q-Quantum. Happy to talk more about that if quantum computing is your thing after. Thank you so much for your time. Really appreciate the opportunity to speak with you today.
Thank you, Jeff. I'm proud to say that we are an Inception member at Global Objects. So thank you again. Big round of applause. So next up on this stage, we have Porous Borders, the thin line between storytelling and reality. And if you have not been to stage 2 yet, you walk through that big old door right there, and then you find yourself to stage 2. And on stage 2, it's going to be AI in the production, post-production supply chain. Again, the schedule's on the back of your badge. You can scan it. we're running a little bit behind, but other than that, we'll take a short break here, and then we'll go into our next programming. Thank you.